PPL, right? It is a general discussion. Now, then we discussed what are programming domains. If you understand the reason for studying the concepts of PPL, it is useful to the programming domain. Which domain the problem belongs to, and to solve that problem, which programming language is appropriate to choose, can be evaluated easily once you know all the features of all possible programming languages. Right? So some domains we serve are scientific, business, artificial intelligence, system programming, and web software, web applications. Right? Now, so language evaluation criteria. Language evaluation criteria. Language evaluation criteria probably includes how far it is flexible for programmer as well as the one who is understanding, who is trying to understand the programs. What is the necessity to understand a program written by somebody else is the one who is working on the program might be leaving the job, might be leaving, might be shifted on to the project, right? So later there may be a chance for enhancing the features that are already included into the software. For that reason, it is required to understand the structure and software programs. So therefore, the evaluation criteria includes some the features like whether it is readable, writable, cost effective, reliable. If it is not reliable, we do not know the amount which we do not know that if you're trying to pay something, if you don't rely the application that you used for paying amount that you that means you transferred some amount to somebody else, but if it is not reliable, you obviously will not be choosing that option to transfer, right? So that so the evaluation criteria includes readability. So simplicity, inside readability, the the features that that one has to observe, or simplicity. It should not be more complex. The one while you are writing, even we also when we write a program, how to use variable names, function names simply, so that you will understand even when you open a program later point of time. So there must be the commenting. Too much the commenting is also not acceptable. Right? So the comments are required, but don't write too much the comments that confuses this. Multiplicity and operator overloading. Right? The other feature is orthogonality. Means when there are the two features being supported by programming language, so somehow there must be a mechanism so that those two features can be clubbed to enhance problem solving facility. If every feature that is there in the programming language is standalone, uh, you cannot have the way to mix those two, right? So it is a difficulty. So therefore, orthogonality is is less. It is not good, right? So it should be good orthogonality. Now, so non-orthogonality in C is, we discussed it, and then too much orthogonality is also uh, it is okay, but might be confusing. Yes. Then we discussed one language evaluation criteria is data types. Adequate facilities for defining data types and structures aid readability. Early Fortran had no record structure constraints. The structures are not there, only arrays are provided, and structures are not there, then you can achieve same effect with the help of arrays. But structures are provided, uh, then the program writing becomes simple, and handling will also be simple, right? So the data, what data types, whether it is implicit or user-defined data types, like that. When as no record or the struct construct, so the field of an object could not be encapsulated within a single structure. So because the world is around object oriented, because every the problem is seen in terms of object oriented, so that feature, if there with the programming language, then it looks closer to the real world. Primitive intrinsic data type should be adequate. Okay? So if it is a Boolean, instead of using Boolean data type, you can also use zero for you can have understanding if flag equal to one, the something, if flag equal to zero, the something, right? So we'll also write most of the times inside the programs, when we go in, we want to test whether we entered into some block. We instantiate flag equal to 1. When you come out of that block, then you want to test whether code entered into that, the execution entered into that block or not. If flag equal to 1, yes. Otherwise, flag would remain 0. We might have used that kind of the technique. If the booleans are already there, then you can have effect of that. And the syntax design, syntax, the identifier forms, and then special words, and then form and meaning, the syntax, the semantics. Where we write a program, uh, and inside the statements, the semantics have to be clearly defined. Right? Then uh, the syntax design should not be too restrictive or lengthy, such as were in 477 basic. In global identifiers could include dashes. Right? So such kind of the confusion should not be there with the syntax. That syntax should be too simple and should not be too complex. If it is like as we read English like statements, then it is more and more good. Right? There should not be too much complexity in understanding the syntax. And then other evaluation criteria area is writability. This is a measure how easily a language can be used to develop programs for a chosen problem. So then the simplicity and orthogonality, support for abstraction. Abstraction is, you studied object oriented, right? Support for abstraction. And then expressivity. This is enhanced by the presence of the powerful operators that makes it possible to accomplish a lot in few lines of code. Okay? So now the writability is also the good thing, right? Then the most one is reliable. The programming language and the features in it, it should be reliable. So this is a property of performing to specifications under all conditions. If we are not sure that such particular code is executed based on meeting some condition, right? So it should be executable, it should perform, there should not be any deviations, right? So reliability is the compulsory, otherwise we do not use such kind of the softwares. And then under reliability you have type checking and aliasing, readability and writability of this, right? And at last the evaluation criteria is cost, the cost effective. If the lot of cost included in software development when you use a particular programming language, cost may be in terms of number of lines of code, maybe in terms of number of employees that we have to deploy for doing the code. Right? It should be simple. Writing and maintaining programs, cost is a function of readability and writability. In terms of readability and writability, the compiling programs for every large systems, this can take a significant amount of time. So the lack of reliability, software failure could expensive, loss of business, well, so loss of business, liability issues. So one has to face more issues when the programming languages are not reliable. The applications designed on those programming languages are not reliable. Other evaluation criteria is uh, that portability and generality, well defined is, right. So these are the evaluation criteria to say that this programming language is good. This programming language is good for this uh, application domain, this domain. It is going to be evaluated based on evaluation criteria. And then uh, next, the reason is influences on language design. So we have to study in this evaluation of the programming languages. Based on the requirement and the programming languages, how come evaluated? Right? Evaluation is based on the need and programming language methodologies. So there are the many programming languages. So it, the diagram may not be uh, visible. So it is a bare machine. The programming language that you install will obviously have to sit on the hardware. So the hardware is inner circle is representing hardware, and everything that should be done with the machine should uh, do the execution by the hardware only, obviously, right? So micro instructions interpreters. There must be a mechanism which interprets, which takes the instructions, and which uh, the responsibility is to submit those instructions and see that those instructions are executed on the hardware and get back the results. And upon it, operating system and hardware. In between, there is a micro instruction interpreter whose responsibility is to have interaction between operating system and hardware. And on top of this, all other applications. We'll see all other applications. So see ADA compilers and Java virtual machines, C compilers, .NET, many interpreters, operating system command interpreters, assemblers, and so many. Right? So so many applications, other applications will be in the outer layer. Right? Now, so Java compilers and the C++, VB, .NET, many more. If any application that you develop by using C, ADA, Java, whatsoever it is, the programming language, that application will be sitting on the outer layer, because when you run that application has to uh, the compile has to do this, right? So therefore it is in the outer layer. We know that uh, you are more familiar with the C language and the C++ language, where it requires uh, to write a program, where it requires to write a program, we use some predefined or built-in functions. For that, we have to include some header files, right? So after that, we'll write code, and then once the code is done,
एक
we'll
क्वेश्चन
have to
पूछूं मान
execute
लो
it.
एक
So it is a
स्टूडेंट क्या
compilation
कहते हैं पेपर
process.
सबको फंसा होती है एक
So
चीज कि यार चार
there
लोग
are
हैं 22
interpreters,
बने हुए हैं उसमें से
there
थोड़े
are the compilers. Based on the programming language, maybe this. So there is a job of interpretation here. So interpretation is to submit directly onto the machine and get the results back. So there are three general translation methods. Those are compilation, interpretation, and mixture of these two, hybrid of these two, alone compilation, alone interpretation, or sometimes some programming languages will use both compilation plus interpretation, right? So in the compilation, so you know what is this? The compilation is a kind of translation, right? Or you wrote a program to get that program executed on the machine. Machine will not be understanding what we wrote. Therefore, there is a need of compilation process. Its job is to convert our program into a machine understandable form of programming statements. Right? So once that is done, that program can be executed on the machine. Right? So, so there are some levels in the process of compilation. Right? So here a compiler translates each compilation unit, class, module, file, depending on programming language, into an object module containing object code, which is like machine code, except that two kinds of references have not yet been put into machine code form, external references and all. Okay. So object code is going to be generated. That object code is machine understandable instructions, is containing machine understandable instructions, identifiers declared within the module that are free to be referenced in other modules. So there is, right? So what is the process of the compilation is, say, this, I'll, so here will there are some levels in the process of compilation. So this is our program, and these boxes are related to the compilation part. At the output of compilation is a result. What is that result? Is not our the program result. Like our program is to add two numbers. If input is 1 plus 2, result is 3, not that. Right? Result of this compilation mechanism is object code. Our code is in our understandable form. This result is in machine understandable form. Then this code gets submitted for execution on the machine. Right? So compilation process will, before this compilation process, the some other process has to begin. That if you include hash include stdio.h, that has to be placed inside our program. Even we wrote 10 lines of program, just because we included a hash include stdio.h, or 10 lines of program is going to be appended with, is going to be prepended with stdio.h program. So therefore, our program will become thousands of lines of length. But our program is only 10 lines, right? So one, so though that the process is pre-processing with the reference to compilation. Pre-processing means before compilation. Pre-processing is done before compilation. Once pre-processing is done, then the job of compilation comes. We are not noticing that this kind of job is happening when we compile a program. Internally, it does. Right? Our source program, after pre-processing, uh, after pre-processing, still will get a source program. Still, that source program is a high-level language form. Right? We call that still as a source, but modified source program. Who modified it? Like macros, hash define, max, 100 kind of statements we'll write now. So those statements are resolved. Sometimes we'll write macros. Sometimes we'll write stdio.h, math.h, conio.h. All those files are going to be replaced. Understand? Now, once that pre-processing is done, then compilation job comes. Right? So compilation, first step is lexical analysis job, lexical analysis, and then syntax analysis, and then intermediate code generator or semantic analyzer, right? And then code generator or code optimizer. You may also see this is optional phase, uh, code optimization. Right? The code optimization is like this. If up to this 100 lines are generated, then if possible, those 100 lines of code may be reduced to 70 lines by applying some techniques. Right? That job is optimization job. Then result of this optimization optional phase is intermediate code. This intermediate code, then from this intermediate code, and the code generator will generate this. So this code generator code generator um, generates object code. That object code is submitted on the computer. Then we'll give some inputs. We'll give some inputs, and based on those inputs, we'll get results. This is not compilation part. This is execution part. Last box is related to the execution, not compilation process. Right? As if as if you do gcc sample.c, you will get executable file a dot out. That a dot out you will execute here. Right? Now, so then you will see the result. Now, so in between this, there is some more job, that is linker job, loader. Then you can notice is highlighted bold terms: linker, loader, relocating, loader, and all. Right? So, what is the job of each? Uh, Before discussing these, we'll see what is the job of each box. The lexical analyzer job is, assume that we wrote a program, we are trying to compile it. Now compilation process begins here. Lexical analyzer. Its job is to read our source program. GCC is a compiler. Na? GCC will read our source program sample.c line after line or character after character, and it divides our source program into units. Those units are called lexical units. So it is a compiler design process. So in the compiler design, uh, every phase is a unit, every box is a unit. It is a deep discussion, right? We do not do that much. So lexical units are generated. What are lexical units? So I'll write int a comma b comma c semicolon is our say statement in our uh, program. So it divides int comma a comma b comma c semicolon. Different units. What are those? A, B, C are divided as a tokens. Those tokens are variables, identifiers. Group them into identifiers. INT is divided, that is grouped as a keyword. Comma, semicolon symbols are identified as a punctuation symbols. So like this, program is going to be broken into different units. Those units are called lexical units or tokens. Different, and those units are grouped into tokens. What are tokens now? Keywords, all keywords, all identifiers, all constants, punctuation symbols, and all, right? And then those tokens are registered into the symbol table. It is a data structure. Those are registered into the symbol table, and those are, and like syntax analyzer job is to coordinate with lexical analyzer, right? So to look for syntactical errors, if you miss comma or semicolon syntax, you will get a syntax error, right? So it is based on, again here you use it NFA, DFA, right? Regular expressions in lexical analysis job. Lexical analysis job is done by uh, the components, or in this, the components used are regular expressions, NFA, DFA job that you studied in other subject. And then syntax analyzer job. So it uses context-free grammar. It uses context-free grammar. Some tools are there in this, so that syntax analyzer will use those tools. Right. Now, will in the syntax analyzer will be in coordination with lexical analyzer to verify syntactical errors. If it passes, its output is parse tree or syntax tree. It will also coordinate with symbol table. It is a data structure. It is a storage, right? And then it will then generate uh, parse tree or syntax tree structure, right? Now, intermediate code generator or semantic analyzer job is to generate intermediate code, right? A mnemonics form of code, right? So it's, if possible, that code is going to be optimized, and then still the output is intermediate code, and then that intermediate code is is used for generating object code, machine understandable form. So here it does not directly generate machine understandable form, it generates a object code, mnemonics, assembly code. Then assembler, a linker, loader, together assembler will generate machine code, machine understandable form. Then linker and loader will come into on the picture here, and then at last we will get machine understandable form of uh, statements like a dot out that is going to be executed. We'll see the results. Linker is responsible for linking together the object modules that comprise a program. If it is a large program, five of your friends might be working on it. You can divide your program into five components. All five of your friends will be working on five different systems, right? Then you worked on it. Then later you have to club them. You have to link them. So whose job it is? Linker job. That means it uses the tables in each object module to resolve references, because variables or references used in some module might be useful for some other module, and so on. Loading, relocatable. So these are all the jobs of the compilation process. What you have to understand is lexical analysis syntax analysis, intermediate code generator, code optimization, code generator. There is another one, error handling. If there is any error, that error, all are connected to symbol table. If there is any error, then error handler will prepare a message and display on the screen. Understand? So that is compilation process. Now, if the compilation, interpretation, and compilation plus interpretation, hybrid evaluation, right? So that is so we'll see that. So interpreter, you might have written programs. Uh, you studied Java, right? So it is interpreter. You studied C. It is a compiler, compilation mechanisms, right? Now let X be a programming language. An X interpreter is a program. For X program C programming language, we need a compiler, C compiler. For X programming language, if X is an interpreter, an X interpreter is a program, right? So that programming language is so interpreted programming language. Therefore, interpreter is required. That interpreter is still a program. That program reads our program and interprets and submits for execution. It is like when you see on the political dais, the interpreters, translators are required because audience here is uh, are unable to understand the speaker language. Therefore, there is one who knows speaker's language and who knows um, the audience language. So that job is the translator job is to read the statement of the speaker and then translate that into audience understandable statements. So that is the job of the interpreter that simulates computer whose native language is X. That is, the interpreter repeatedly fetches next instruction, right, from X program being interpreted, decodes it, and executes it. A computer is itself is an interpreter of its own machine language, except that it is implemented in hardware rather than software. Then what is the difference of the compilation and interpreter? Both are used for executing our programs. So compilation is done on the entire program. For the entire program, object code is generated. Then the execution starts. But interpreter, for every line, object code is generated, and that line is executed and takes next line. And for the next line, object code is generated and executes, right? So it goes line by line. Understanding. But whereas a compiler for entire program, object code is generated first, and then that object code is submitted for execution. But not that is not true in case of interpreter. All lines in all lines in a program are not translated into object code first. Line, it takes a line, translates into object code, and then submits for execution. Line after line by line, a translator. Right. So there are the programming languages like this where we use interpreter, pure interpretation. Source program. So program this the diagram looks as that the source program is uh, read by the interpreter and giving us the result. But you have to understand it like this. It takes a line, submits, and takes a line and submits. It's a continuous process. If 10 lines are there in our program, if there is an error in a third line, first line, no issue, it is going to be executed. Its result is going to come on the screen. Second line, is okay. And then if there is error
समझे?
present in the
मान ले
third
एक
line,
किसी ने देखिए
then
गैंग रेप सबको सजा
reports
होती है इक्वली, मान ले 4
error
लड़के गए
message
तीन
related to the
उसमें
third
से
line
2 अंदर
and
गए, 3
skips
अंदर गए, एक
fourth line onwards. Does not look for execution of the fourth line, but it is not so in case of compilation. All the lines are translated first. That is the difference between compilation process and interpretation process. The next one is hybrid. It is like you execute Java programs. It is both compilation plus interpretation. Right? We studied Java. Now, so it is language evaluation, methods, source program, lexical analysis, syntax analysis, intermediate, and then interpreter comes. Because it is hybrid, uh, once compilation is done on that object code, interpretation is done. Right? Here is a program is a translated uh, into object code first, and then JVM will be acting as the interpreter. Right? So I think we are running out of the time. If are you there? You know programming languages. Only thing is that we have to understand many more features. That's it. Hello. So I'm closing then. Uh, Hello.
Yes, sir.
Thank you.